All right, let's start things off here. First off, let me introduce myself. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you are an educator at the high school level involved in CTE training, if you're a college professor or industrial trainer teaching programming skills required in manufacturing, if you're a company looking for ways to demonstrate their software-based solutions, or if you're just someone looking for ways to make IoT-related concepts easier to understand to employees or customers, I believe this presentation will offer some important options for you to consider. Let's start off first by considering the skills gap. Now, if you've attended any of our other fischertechnik education webinars, you've probably heard me discuss the importance of STEM education. Now, STEM, of course, is the acronym for science, technology, engineering, and mathematics, and it should go without saying that STEM education has been perhaps the most discussed topic in education over the last decade. As most of us are aware, the push for developing STEM skills in students is in large part to help to best prepare them to take their place in the modern workforce. Not so long ago, when our parents or perhaps even our grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. As it ties in directly with the solution we will be looking at in this presentation, let's consider that last skill area I just mentioned, that of a PLC programmer. Well, first off, for anyone who may not be familiar, let me explain exactly what a PLC is. The term PLC is an acronym, the letters of which stand for Programmable Logic Controller. Now, essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes typically found in an industrial setting, such as an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. Just to get a clear idea of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer's salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. In fact, when I was preparing this presentation, I took a glance at the list of current job openings for PLC programmers on nuvu.com. This was in late February, and at that time they showed 15 positions being advertised with salaries over $75,000, two of which even listed salaries over $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC programming programs at the colleges and university level. And at the same time as this, the workforce of tomorrow is getting their training. At the same time, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools offering such programs. So how long does it take to learn PLC programming? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient in all 5 of the most widely used PLC programming languages, which you see listed on your screen now, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are many other options available. There's high school CTE, or career and technical education programs. There are, of course, adult continuing ed programs, vocational training, technical training in trade schools, and as I mentioned, employer-sponsored incumbent worker training programs. Now, that all being said, the question that still arises for the educators, whether it's in the university or vocational school classroom, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it realistic and also make it hands-on? But before we go there are other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be a company involved in creating or marketing a new type of software-based solution that's looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturing company looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's even a company looking for to demonstrate their services or solutions in a public setting, such as a trade show. In each of these cases, and many more of course, there is a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of fischertechnik industrial simulation and training models. Now, these models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate in both appearance and function various automated robotic machines and systems commonly used in commercial manufacturing. But before we look at each of these models, let me provide you with just a little bit of background. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. Now, what makes this building system unique is that unlike other popular construction systems where the components are designed to simply stack, Fischertechnik was created with more of an engineering mindset. The core building block in the Fischertechnik system is designed to enable attachment from all 6 sides, and because of this, it allows for almost unlimited design possibilities. Many of the parts are designed to slide together and lock in place, and the hundreds of different parts available will also help students to address very specific design needs. The Fischertechnik system was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in the construction and the automotive industry. Now, Mr. Fischer, at the time of his death in 2016, had held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, and this was back in 1949. And he was also the creator of the expanding nylon wall plug, which everybody's used, where you basically get a little plug that's used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction. They also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of Fischertechnik sets, whether those intended for the retail market or those intended for classroom use, has always been on helping to foster an understanding of technology. Now, many of the products offered by Fischertechnik for the education sector are subject-specific sets, which focus on different STEM-related areas, and these would be things like mechanics, pneumatics, robotics, or, for example, renewable energy. Now, in many of these sets, students will be asked to build a progression of models using, again, the unique Fischertechnik building system, and then as they build this progression of models, they can perform various experiments which allow them to explore and understand different aspects of the subject being studied. Now, there are also sets that are designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students will dive deep into engineering and learning all aspects of the design process, which will require them to do things like work in groups and create various devices and automated machines to meet the criteria that are being put forth in a series of real-world scenarios throughout the curriculum. And these real-world scenarios are going to be they're going to require a lot of trial and error experimentation and research and documentation, what have you. So a lot of real-world skills that are being learned here. Now, the line of fischertechnik simulation solutions, which are the focus of today's presentation, are something much different. The line consists not of kits, but in this case, these are a series of pre-assembled small-scale models, which again replicate in appearance and function various automated robotic machines and systems. Models in the fischertechnik simulation line include things such as conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. This model consists of 4 individual workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, which all work together as one self-contained material cycle. But before we begin to look at the models in the simulation line in more detail, let me briefly outline some of the advantages of using fischertechnik solutions. Now, I will apologize at this point, as the first few things that I'm going to mention here are things I've touched on before, but in each case, I think it's worth repeating. First off, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in the programming or PLC-focused learning environment. The models are once again designed to realistically replicate, in both appearance and in function, common automated systems, things again like conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop sized, they are not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next factor is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each model in the line is also available in 2 different versions. The first version is a 24-volt version, which is designed for use with industry-standard PLCs. Now, whether you use Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or many others, you can control these 24-volt models with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language. If you like ladder diagram, you can use that. If you like sequential function charts, function block diagrams, structured text, or instruction list format, you can use that as well. Now, please note that with the 24-volt versions we'll be looking at, no PLC is actually included, so you'll have to provide that. And all programming and programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. Of course, we don't think this should be an issue, as these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. On the other hand, for non-industrial users and for educators not versed in or familiar with PLC programming or who aren't focusing on PLC programming, there are also 9-volt versions of each of these models which are available. Now, these 9-volt versions ship pre-wired to fischertechnik's own proprietary robotic controllers, which are called the Robotics TXT controller, and each controller is pre-programmed using fischertechnik's own RoboPro graphic programming software. In each of these cases, the only additional component required with the 9-volt versions will be the addition of 1 or more 120-volt power adapters as specified with each model. Otherwise, in most cases, these should be ready to use right out of the box. Now, if you're involved in demonstrating or exploring IoT, also known as the Internet of Things, besides the fact that many end users have adopted many of the models in the primary line of simulation and training solutions for IoT purposes, fischertechnik now also offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud control in what is sometimes referred to as Factory 4.0. With this model, it's designed to be both controlled and monitored from a special web-based dashboard. We will, of course, discuss this in more detail a little bit later in the presentation. And our final advantage, fischertechnik simulation models are cost-effective. While I won't get into naming different product names, I will say that if you've ever looked into any of the other hardware-based industrial simulation options which are available in the marketplace, you'll probably notice that the entry point for many of the products can easily be $20,000 to $30,000 or even much more. Now, fischertechnik simulation solutions, on the other hand, are available at only a fraction of that price, as well as also being compact, realistic, and high-quality learning and demonstration tools. So with all that being said, let's look at each of the models which are available. The first model we're going to look at is the vacuum gripper robot, which you see on your screen now. Now, as you can see, or you will see in just a second here, the vacuum gripper robot is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you might see in certain parts of this video, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. The 24-volt versions of this model, as well as all the other 24-volt models we will look at later, each have a relay board for motor polarity reversal and both a multi-pin connector with 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as with all 24-volt versions, will require you to provide the PLC and the programming. The 9-volt version, which is the version you actually see in this video, will once again come wired to the fischertechnik robotic TXT controller and will again ship fully pre-programmed using RoboPro graphic programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. I will also mention that for this and all the other models we're going to look at today, the specs are also detailed in the product listings, which are found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. The next model we are going to be looking at is the automated high bay warehouse. This model features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, and 9 individual storage spots. Components of this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each. I will note that this model is a favorite among educators I know who teach programming, and the reason for that is because it gives you a lot to work with in regards to, for example, the movements of the picker mechanism, as well as the precision required to properly store and retrieve each piece on each of the shelves, each step, of course, which will require its own specific coding. Now, the dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Once again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 26 pins, with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and programming. The 9-volt version again is pre-wired to the pre-programmed robotic TXT controller, and only one 120-volt power adapter is required. The next model we're looking at is the multi-processing station with oven. You will be looking at it in just a second. Oh. Let's see here, multi-processing station. There we go. Now the model we're going to see here features a furnace simulation with a pneumatic sliding door. There is a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches with a weight of about 11 pounds. Also available in both 24-volt versions for use with the PLC of your choice. The 9-volt version in this case is connected to 2 robotics TXT controllers, so 2 120-volt power adapters will be required for all operations. The next model in our progression is the sorting line with color detection. This simulation features a system for detecting workpieces of different colors and sorts them via a conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical sensor. The dimensions for this model are approximately 20 by 14 by 12 inches with a weight of about 10 pounds. Now, as with the models we've looked at before, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, you will need to provide the PLC and the programming. The 9-volt version again comes pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required. The next model is the factory simulation, which combines the 4 models we've just reviewed, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with oven, and the sorting line with color detection into one self-contained material cycle. Getting just a little bit of lag here. Which hopefully will straighten out in just a second. Okay, there we go. The cycle you're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot and then moved to the multi-processing station with oven. After the workpiece has been processed by this machine, It is then sorted by color in the sorting line with color detection before again being moved by the vacuum gripper robot to the automated high bay warehouse for storage. As we've already discussed the components of each model previously, I'm not going to belabor it by restating them here, but what I do want to discuss are the dimensions of this model as a whole. As it again combines 4 individual models into one cycle, it has a much larger footprint of approximately 39 by 31 by 16 inches, and it has a weight of between 43 and 46 pounds, depending on whether we're talking about the 24-volt version or the 9-volt version. Now, due to these dimensions, note that this model will only be shipped flat as freight on a pallet. And I also want to point out that the factory simulation models tend to be in high demand, so please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. A few other things to note. First, this is again available in both 24-volt and 9-volt versions. Now in this instance, the 9-volt version is wired to 5 robotics TXT controllers. Now, as such, it will require 3 120-volt power adapters because of the way that they're daisy chained together. Now, as always, the 24-volt version will require the end user to provide all PLCs and programming and any other hardware required. Let's just see here. This is lagging again. As always, the 24-volt version, as I was saying, will require the end user to provide all PLCs and programming and any other hardware required. Again, each station of the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the 2 factory simulations we've just discussed, who may want to transport the model or just to protect it when it's not in use. Now, the travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of approximately 53 pounds. Please note that even when using the travel case, these models will still need to be shipped flat. The next model is a basic conveyor belt. This is a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as desired. Components of this model include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 14 by 10 by 4 inches with a weight of under 2 pounds. Now, as before, this is available in both the 24-volt version, as you see here, and also 9-volt versions connected to the robotics TXT controller, as shown here. One 120-volt power adapter is required for all operation. The next model is a variation of the conveyor belt, which includes a punching machine. This features essentially the same conveyor as we just looked at, except that this time with a machining station built in. Components on this model include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches with a weight of about 3.5 pounds. Again, it's available in both the 24-volt version as shown here and the 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. The model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components of this model include the 4 conveyor belts, just as I mentioned, 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions of this model are approximately 19 by 18 by 11 inches with a weight of about 8 pounds. And again, it's available in both the 24-volt version for use with PLC and a 9-volt version wired to the pre-programmed robotics TXT controllers, 2 of them in this case, and requiring one 120-volt power adapter. Next up is a variation on the idea of a pick-and-place robot, the 3D or 3-axis robot. The 3-axis robot has gripping forceps which it uses to help it quickly and precisely position the workpieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or back 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model are approximately 19 by 16 by 9 inches, and it has a weight of about 6 pounds. As with the other models we've looked at, this is again available in both a 24-volt version for use with the PLC and programming of your choice, or a 9-volt version wired to a pre-programmed robotics TXT controller and requiring one 120-volt power adapter. And that concludes our look at the first 9 variations of simulation models, all of which are available in both 24-volt versions and 9-volt versions. The next simulation model is designed specifically to address the topic of cloud-based monitoring and control. And this is the Training Factory Industry 4.0. This model was designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a large scale. Now, as the following video provides a nicely narrated overview of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The 6 fischertechnik TXT controllers control the learning factory. The controllers communicate with each other via standard MQTT protocol. The controller programs are written in C, C++, and the controllers arrive with the programs already loaded on them so that they can be used right away. The programs can be changed and customized. The sensor image data are used and monitored in the fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The high bay warehouse is organized chaotically. There is no fixed space for a material to be stored. The system simply recognizes the next available space. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. Production data is written on the material at the end of the production process. Finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Well, that was fairly impressive. I hope you'll agree. Now, the following topics can be addressed with the fischertechnik Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, linking of production and materials planning data, connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C, C++. Now, as you just saw, this model incorporates many features not found in the models we've previously discussed, besides just most notably, the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, enables the positions of each piece in the work cycle to be mapped. And the use of MQTT, or Message Queuing Telemetry Transport, that allows the network TXT controllers to communicate with each other. Now, as this screen says, the Training Factory Industry 4.0 is available in a 9-volt version that's pre-wired to 6 robotics TXT controllers. Now, unlike all the other 9-volt versions we've looked at previously today, these are programmed not using RoboPro, but instead using C, C++. Once again, all of the programming is preloaded into the controller so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF, you should be able to get started quickly. Dimensions are approximately 39 by 31 by 16 inches with a weight of approximately 53 pounds. Now this 9-volt version will require the addition of 3 120-volt power adapters and the ability to access the internet, as well as a tablet or device for accessing the cloud-based dashboard. Now, as with the 2 factory simulation models we discussed previously, we recommend the travel case to help protect your model during the transport or storage. We are also happy to announce that as of August 2020, the 24-volt version of the Training Factory Industry 4.0 is also available for shipment. Now, while the 24-volt version is in many ways similar to what we've just discussed, let me briefly outline how it is different. First, it's a bit of a hybrid in that while requiring a PLC for operation and control, it also incorporates one fischertechnik Robotics TXT controller. The TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. Now this allows the option for not only presenting and using data on a dashboard in the fischertechnik cloud, as we just saw with the 9-volt version, but also to be able to display data and calibrate the stations of the factory in a Node-RED dashboard. Now this model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These of course ship as part of the assembled training factory and are connected to the PLC via terminals. Now among other things, these latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, which is pulse width modulation. And they also have push-pull output stages for photo transistors and for buttons. And finally, one of the most important new features, unlike any of the previous 24-volt models we've discussed today, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program. Now this program is created in structured text format, ST, and was created based upon a Siemens S7 1500 PLC, and this is available for download on GitHub. Of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program, and the source codes needed for any of this are also available for download from GitHub. All of this information and much more is included in the 152-page PDF manual, which can be downloaded from the fischertechnik website. And that provides an overview of the Training Factory Industry 4.0 model. Of course, you might well be wondering how much these models cost, so with that in mind, let's take a quick review of each option I've discussed, along with the pricing for each. The vacuum gripper robot, the 24-volt version, is $899 each. The 9-volt version is $1,199 each. The automated high bay warehouse in the 24-volt version is a $1,035 list price. The 9-volt version is $1,319 list. The multi-processing station with oven, $989 each for the 24-volt version, $1,479 each for the 9-volt version. The sorting line with color detection in the 24-volt version, $819 each. In the 9-volt version, $1,129 each. The factory simulation in the 24-volt version, $3,729 each. And in the 9-volt version, $5,239 each. The conveyor belt, the 24-volt version is $220 each. The 9-volt version is $519 each. The punching machine with conveyor belt in the 24-volt version, $289 per unit. In the 9-volt version, $599 per unit. The 3D robot In the 24-volt version, this is $829 per piece. In the 9-volt version, it's $1,099 each. The indexed line with 2 machining stations. The 24-volt version is $879 per unit, and the 9-volt version is $1,399 per unit. And finally, the Training Factory Industry 4.0. In the brand new 24-volt version, $7,365 each. Again, this includes the sample program. The 9-volt version, $6,495 each. Again, since we've touched on these things before and we haven't gotten to the pricing for them, the 120-volt power adapters for the 9-volt models are $12.99 each, and the travel and storage case, which can be used for all factory simulation and training factory industry 4.0 models that we've looked at, those are $1,000 per unit. So at this point, I would normally have you ask some questions, but since we're having a little bit of a problem with the Zoom chat today, I will instead ask that if you do have any questions, you refer to the email on this page. So if you'd like to take the next step, if you would like to request a full color brochure and current pricing, if you would like to ask any questions directly, which I know you're unable to do here, if you would like to request a quote, or if you'd like to speak with your dedicated educational representative, you can call us. Our number toll free here in the US is Studica, 888-561-7521. If you have any, as I said, if you have any questions, would like a quote, what have you, you can email us at info@studica.com, studica.com, or if you have any questions specifically directed towards me about any technical aspects of what you've seen, any aspect of anything Fischer Technic related, whether it's something I've covered today or something I haven't touched on, you can email me directly as well. My email is lancezurek, LANCE.ZUREK @studica, studica.com. So on that note, I thank you all very much for taking the time to attend. Hope you have a great day, and we hope to hear from you soon. Thank you very much.